Let's start the transformation of functions unit with, or lesson with the calculator. So get that out. And let's put into y1 the absolute value of x. So remember, you go to math and num, and it's right there. And then go to y2 and let's plug in math num, absolute value of x plus 2. Zoom 6 for the first time and then graph. This moves 2 up. You probably already knew that. Now change it to minus 2. And I'm sure you can tell me it's going to go 2 down. All right, so then let's take and go back there and let's go inside. I'm going to put the cursor on the in between x and the bar and do second insert and do minus 2 and get rid of the minus 2 on the outside. So you might think it's going to go to the left, but it goes to the right, which is the opposite, 2 to the right. And if we put a plus in there, it's going to go 2 to the left. Next, go back to y equals and change the number in front. So I'm going to do second delete, which is going to insert. And I'm going to insert a 3 in front of that. And I'm going to get rid of the plus 2 on the inside. And when I hit graph, watch, it gets steeper, skinnier. That's called a vertical stretch. And then go back and change it to 1/3 in front. So I'm going to do second insert 1 divided by. Now I think that's going to be a problem, so I'm going to put that in parentheses. So I think I have to go second insert here, parenthesis, go back to the beginning, second insert parenthesis, and now I'm ready to graph it. And look at it, gets wider. That's called a vertical shrink. Okay, so look at the, I'm going to go back in here. It's easier to see if we change it back to 3. So I'm going to go and delete the parenthesis, the 1, the divide, and the other parenthesis. And if you look at the table of values, you should notice the y-coordinates get multiplied by 3. When I put 1/3 in, they get multiplied by 1/3. If I go and I put second insert and I do point, and I just, and then I delete the 3, and I look at 0.5 times the absolute value of x, you should notice that they are dividing by 2, the y-coordinates. The x-coordinates are staying the same. The last thing is now take and get rid of that and replace that with negative, not minus, but negative. And when we do that and hit graph, we should see a reflection over the x-axis. Going back to our notes now, we can complete them. We have y equals absolute value of x, and then if we did absolute value of x plus 2 and absolute value of x minus 2, that is going up and down. So this one goes up k, down k, and it's a translation of 0 left and right, and you're going up or down. Okay, so we do that with a symbol capital T, 0, comma, K. The next one was y equals absolute value of x. And then it was absolute value of x minus h, which moved to the right. And I'm going to do absolute value of x minus 2. And then absolute value of x plus 2 would move to the left 2. So that's absolute value of x plus 2. So this moves to the right. H, this one goes to the left. H, this is again a translation. But now you're moving left or right amount h, and you're moving up or down 0. So we say capital T and then subscript h, comma 0. Let me make that a little more legible. So h, comma 0. Okay, back in audio. Next piece, a is a positive integer greater than 1. So absolute value of x, and then if we make a like 2 or 3, so we'll go to absolute value of x, then it gets skinnier, steeper. It's called a vertical stretch. And then if we do like y equals absolute 1/2 times the absolute value of x, then it gets wider. And this is changing of the y coordinates. So this is like a shrink. So this one is a stretch, and this one is like a shrink, vertical shrink. So the conclusion is basically you keep the x coordinates the same, and you multiply each y coordinate by a. So it's not a dilation or anything like that. All right, and the next one is the reflection over the x-axis. So that's just our x-axis, which is a reflection over the x-axis. All right, then describe the graphs of 2 through 6 in terms of the graph for number 1. So that should be easy now. So absolute value of x minus 3 is you're moving to the right. 3, this one should be moving up. 3, this one you've got two things going on. You have a reflection over the x-axis, and then you will be moving to the left 3. Number 5, you multiply the y coordinates by 3. This is that vertical stretch. And the last one, you multiply the y coordinates by 1/3, which is that vertical shrink. If you go to the next page with me, now we are looking at parabolas. Same idea. So this one is going to go up k and down k. So just a x squared. This one's going to go up. So if it was, say, x squared plus 2, this one would go down if it was x squared minus 2. So it's that translation of 0, comma, k. And k can be negative and go down, or k can be positive and go up. The next one was that shift left and right. So x squared, y equals x squared, x minus h, you think goes to the left, but it goes to the right. So maybe that's x minus 2 quantity squared, and then x plus h quantity squared would go to the left. So maybe that's x plus 2 quantity squared. So this one that we just did went to the left, h. This one goes to the right, h. So that one was a translation of left and right, h whatever, and up 0. So h is whatever number that it is. And then we had the same thing going on with putting the a in front. If it is, say, a 2, it's going to get skinnier. So the first one was just x squared. The next one would be, say, maybe 2x squared. And then if it is, say, 1/2 x squared, then that is the one that's the vertical shrink gets a little wider. So our conclusion is that you multiply the y coordinates by a. You keep the x coordinates the same. The last one, it's that reflection in the x-axis. So the conclusion is a reflection in the x-axis. Again, describing the graphs, same idea. It's going to go right 3, up 3, reflect over the x-axis, and we're going to go 3 to the left. This one is multiply the y coordinates by 3. It is not a dilation, and this one is multiply the y coordinates by 1/3. This one was a stretch, shrink. Next page. Okay, one last example here says use a graph to find the solution. So I'm going to, into my calculator, put y1 equals absolute value of 2x plus 1. Into my calculator, I put y1 equals absolute value of 2x plus 1. Then I'm going to put, I'm going to graph that. So when I do that, I get a table of values. So if I go to the calculator and I press on, clear those out. So I'm going to go math, num again, absolute value, 2x plus 1. And I'm going to check out my table of values here. So I can see the rainbow. I've got the 5 and 5, 3 and 3, 1 and 1. There's got to be a minimum in there somewhere. to find that minimum. So when I hit graph, it looks like it might be at 0, 0, but I'm pretty sure it's not. So I'm going to go second trace minimum and put the cursor to the left, hit enter, put the cursor to the right, hit enter, and my minimum, remember this is 0.5, negative 0.5, you know, it's 0.000011116, so it's really supposed to be negative 0.50. You can go to second trace value to verify x at negative 0.5 has a y value at 0. So I know that's my minimum. So I am at negative 0.50. That's my minimum. Now, I'm going to graph this. Okay, so there's y equals absolute value of 2x plus 1. And then I am interested in y2 equals 5. Now, I know that where that is without having to use the calculator. Let me go in blue. There's y equals 5. So I'm going to use this graph now to find the solution of all these. So I need to know these intersections. I need to know the x-intersections. The y is 5, I can tell that. I can kind of count it. But just to review that, let's go back to the calculator real quick. And let's type in y2 equals 5. And do second trace intersection, choice 5. Just move the cursor close to one of the intersections and hit enter, enter, enter. Intersection 2, 5. Then do it again, second trace intersection. Now, I don't really want to go down the graph, so I'm going to hit the down arrow, and that's going to jump onto the y equals 5. I'm going to bring the cursor over and hit enter, enter, enter. I do not need it to be on the intersection. So my two intersections are 2 and negative 3. That's what I thought they were. So this is 2, and this one is negative 3. And I don't really care what the y coordinates are. They're not going to help me answer this. So for this first answer, we get negative 3 equals x and 2. Now for the second part, I'm looking for where is the absolute value of 2x plus 1 graph greater than 5. So let's put that in a different color here. So where is this above 5? Where is this above y equals 5? Well, right here. So you can see they're kind of going in opposite directions. So it's an or, which makes sense. We have gray tor. So the answer would be using those intersections. X is less than negative 3, or x is greater than 2. And then for the last one, I'm looking for where, this is an and now, I'm looking for where is this absolute value of 2x plus 1 graph below 5. Below y equals 5. And it's right down here. And you see how it's connected. So this is an and. So my answer would be negative 3 is is less than x is less than 2. So that's how you solve it using the graph. That ends today's lesson.